you multiplying first row with minus 2 and then minus 1, so minus 1, this is become minus 8, this is 0 minus 2, so you will get minus 2 0. Similarly, how we become third row, so you can see 3 minus 3 0, minus 1 minus 0 minus 1, minus 12, then minus 1 minus 1 minus 2, okay, and then the fourth row is minus, this is 0, then this is also 0, this is minus 4, and this is 2 plus 2 4, so this is 4 minus 4 0. So finally you will get 3 C1 plus C4 is equal to 0, minus C2 minus 8 C3 minus 2 C4 is equal to 0, 6 C3 is 4 C3 is equal to 0, and 4 C3 minus 4 C4 is equal to 0. So C1 is 0, C2 is 0, C3 is 0, C4 is 0, okay, because you can see the third equation 4 C3 is equal to 0, so C3 is 0, put the value of C3 is equal to 0 in the last equation, you will get C4 is 0, then C3 C4 0, put in this equation, second equation, you will get C2 is 0 and then C1 is equal to 0. So it's quite easy to solve. So all the coefficients are 0, C1 C2 C3 C4, and that's why this side is linearly independent, and using that important theorem which I explained before to solve this example, S is a basis for a vector space V, where V is a set of 2 cross 2 matrix, okay. So the next question, question 5a, find eigenvalues and eigenvectors of the matrix A, that is equal to 3 1 4 0 2 6, the second row is 0 2 6, the third row is 0 0 5. This question was asked in 4 marks. Here A is a upper triangular matrix. You can see upper triangular matrix means there is a square matrix, right? In a square matrix, in main diagonal entries, except the main diagonal entries, below that main diagonal entries all the elements are 0. So same situation happen here. Similarly, you can understand that what is the meaning of lower triangular matrix. In a main principal diagonal elements, above that main principal diagonal elements, all the elements are 0. So that is called lower triangular matrix. This matrix is a upper triangular matrix, and in lower triangular or upper triangular matrix, to find eigenvalues it's quite easy. Directly you can write down the main principal diagonal elements are exactly the eigenvalues. So that's why I written our eigenvalues directly. Otherwise you have to find A minus determinant of A minus lambda I is equal to 0 and solve this determinant. You will get the one polynomial in terms of lambda. If your matrix is in 3 cross 3 matrix, your polynomial is in form of lambda cube, starting with lambda cube, and simplify that equations and find the value of lambda, okay. But here you don't need to solve this example by this method, okay, because this is the upper triangular matrix, and as I told you that in upper triangular matrix only the main principal diagonal elements are our eigenvalues. So you can see these are the eigenvalues 3 2 5 are eigenvalues of A. Now to find eigenvalues we have A minus lambda I eigenvectors, okay. A minus lambda I into x is equal to 0. So 3 minus lambda, just you have to add minus lambda in your main principal diagonal entries. 3 minus lambda, 2 minus lambda, 5 minus lambda. This is 1 4 0 0 0, okay. x1 x2 x3 0 0 0. Now we want to find eigenvectors, correct? So put lambda is equal to 3 first, and then find eigenvector, then 2 and then 5 in these equations, okay. So first of all we put lambda is equal to 3 in these equations. So let's see what happened. Okay, using this matrix we convert in equations. This is 3 minus lambda into x1, that is equal to 0, plus 1 into x2 plus 4 into x3 is equal to 0, then 2 minus lambda into x2 plus 6 into x3 is equal to 0, plus 5 minus lambda into x3 is equal to 0. Now for lambda is equal to 3, put lambda is equal to 3 in this equation, so you will get x1 plus x2 plus 4x3 is equal to 0, then minus x2 plus 6x3 is equal to 0, and then 0x1 plus 0x2 plus 2x3 is equal to 0. Put lambda is equal to 3 here, so you will get 2x3 is equal to 0. So finally you will get this eigen vector 0 0 0. Okay, next put lambda is equal to 2 in these equations, you will get x1 plus x2 plus 4x3 is equal to 0, then 6x3 is equal to 0, and then 3x3 is equal to 0. So x3 is equal to 0, x2 is equal to k, and x1 is equal to minus k. Okay, when you take x2 is equal to k, x1 is equal to minus k. For lambda is equal to 2, k into minus 1 1 0, where k belongs to R. For lambda is equal to 5 minus 2x1 plus x2 plus 4x3 is equal to 0, 0 into x1 minus 3x3 plus 6x3 is equal to 0. Using Cramer's rule, you can find the value of x1, x2, x3. So x1 into 1 minus 4, sorry 1 4, this is minus 3 6, minus x2 how you find, that is equal to minus 2 4, this is 0 6. Similarly x3 minus 2 1 0 minus 3. Okay, now so x1 is equal to, this is 6 plus 12, so 18k, x2 is equal to, this is minus 12, so minus x2 is equal to minus 12k, so x2 is equal to 12k, and x3 is equal to, you will get 6k. So the value of x1 x2 x3 is equal to 6k will be common, so 3 2 1. So our eigenvector corresponding to lambda is equal to 5 is 3 2 1. Now next question, question 5b, verify Cayley-Hamilton theorem for the matrix A 2 minus 1 1 minus 1 2 minus 1 and 1 minus 1 2, and hence find A inverse. Now what is the Cayley-Hamilton theorem? First of all, the Cayley-Hamilton theorem says that every square matrix satisfies its characteristic equation. Okay, and how we find characteristic equation? Characteristic equation is, for any square matrix, is determinant of A minus lambda I is equal to 0. So when we solve this determinant, as I told you before that if 3 cross 3 matrix, you will get the polynomial in term of lambda starting with lambda cube, and instead of lambda you have to put our matrix A, and then you have to check in this example that it satisfies or not. So let's try to solve it. A minus lambda I is equal to 2 minus lambda. In the main diagonal elements we have add minus lambda, so 2 minus lambda 2 minus lambda 2 minus lambda. You can see in main principal diagonal elements all other elements are same as it is, that is equal to 0. Now we are solving this determinant, so you can understand that how we solve this determinant. 2 minus lambda in bracket 2 minus lambda into 2 minus lambda minus 1 plus 1 into minus 1 into 2 minus lambda. So plus 1 into lambda minus 1 plus 1 into minus 1 plus lambda, that is equal to 0. So 2 minus lambda will be common. In bracket you will get lambda square minus 4 lambda plus 3 plus 2 lambda minus 2, that is equal to 0. So finally we get lambda cube minus 6 lambda square plus 9 lambda minus 4 is equal to 0. Okay, now using this polynomial you will get the polynomial in terms of lambda, starting with lambda cube because we have a 3 cross 3 matrix. So next is using Cayley-Hamilton theorem, we get a cube minus 6a square plus 9a minus 4i is equal to 0. That we have to prove, right? A cube minus 6a square plus 9a minus 4i is equal to 0. But 0 is a 0 matrix, right here. So first of all we have to find a square and then we have to find a cube. So a square, what is our a? This is a square means multiplication of a with a. So both are 3 cross 3 matrix. So definitely we can multiply these two matrices. 3 1 4 0 2 6 0 0 5, 3 1 4 0 2 6 0 0 5. How we multiplying to matrix multiplication? The condition for the matrix multiplication, the number of column in a first matrix that is equal to the number of column, number of row in the second matrix, that two are equal. Here all are equal, number of row, number of column, right, in both the matrix. So there is no issue to multiplication of these two matrices. So pick up the first row of the first matrix and multiplying with each column of this matrix, right? Pick up the first row 3 1 4 multiplying with 3 0 0, so you will get 9, right? So that's why then pick up the first row with multiplying with the second column, you will get 3 plus 2, right, and then 0, so 5. Okay, and multiplying with the third column, so you will get 7, right, plus 6 13, okay, and plus 20. Okay, so similarly you can so this is our matrix a square, 6 minus 5 5 minus 5 6 minus 5 5 minus 5 6. Then a cube, the value of a cube is 6 minus 5 5 minus 5 6 minus 5 and then 5 minus 5 6. Okay, so finally you will get this matrix 22 minus 22 minus 21 minus 21 22 minus 21 21 minus 21 22. Put the value of this aq a square in this equations. 22 minus 22 minus 21. Okay, you can see this is our a cube minus 6, this is a square, plus 9a minus 4i. I means identity matrix. So just verify one of the element. This is 22 minus 36, right, that is minus 14 plus 9 into 2 plus 18, so plus 4 minus 4, you will get 0. Okay, similarly you can check all other elements one by one. So definitely you will get all the elements, the addition of all the elements becomes 0, and that's why you will get 0 matrix. So Cayley-Hamilton theorem is satisfied here for this particular matrix that we have to prove, and we already prove now. Okay, So this question was complete. Now next question. Okay, another that remember that we have to find A inverse, right? That is also a question. Only the Cayley-Hamilton theorem that we satisfied. Okay, that is satisfied here. Verify Cayley-Hamilton theorem for the matrix A and hence find A inverse. So using that statement, this is our Cayley-Hamilton theorem. The statement of Cayley-Hamilton theorem that every square matrix satisfied its characteristic equation. So a cube minus 6a square plus 9a minus 4i is equal to 0. Now using this equation we find the A inverse. What we have to do, left hand side and right hand side we are multiplying with A inverse. So A inverse into a cube minus 6a square plus 9a minus 4i, that is equal to A inverse into 0 matrix. So right hand side definitely you will get 0 matrix. See, this is our first equation. So the left hand side you will get a square minus 6a plus 9i minus 4a inverse, that is equal to 0. So 4a inverse is equal to a square minus 6a plus 9i. So put the value of a square. Now you have already the value of a square. Okay, so this is our a square, this is a, and this is identity matrix. So when you add these matrices you will get 6 minus 12 plus 9. Okay, so 6 minus 12, that is minus 6, plus 9 you will get 3. Similarly other elements, when you add it, other elements also you can verify. 3 1 minus 1. So our 4a inverse is equal to 3 1 minus 1, 1 3 1 minus 1 3 minus 1 1 3. So finally A inverse is this matrix 1 by 4 into 3 1 minus 1 1 3 1 minus 1 1 3. So here we complete this question paper up to this question. Thank you. Have a nice day.